Hi, this is Martin, section D. We're going to do a 2-second recap and then proceed. We've covered the fact that we have got these integrated models and that they are interrelated just with a click, and that is done with linked identity at the main level, which is the rows. We're able to move through that. We've discussed all that previously. What we really need to do is discuss what's on the left-hand side, which are the data in time models. There are several. So what we have is the basic, which is set at grid model, building, index, and hex. Grid model is like it stands for, a grid system by state, much like a standard histogram. You can drill down to the nth level and have a look at what it looks like. Or we can obviously look at it in total again. On that, that's the grid. I have to go fairly quickly, unfortunately. Can switch between the grid and the building model, which is similar to the basic model, except what we're looking at, have a look, is 1/100th 1/100th of a calculation, or 1/1000th, or 1 in 10,000, or 1 in 10 million, because it counts numerical values by little blocks in comparison to one another, and you get an accurate representation of the data. You can see the highest one is obviously this one over here, which is District of Columbia, which we've been discussing the whole time. Comes up in the AI evaluation, exactly the same thing, but observationally, you can see in a second that that is clearly the highest increasing value in the entire plethora of data. It can be seen visibly and demonstrated in obvious terms. So, within the building model, we're able to, if I'm not mistaken, we'll take it one stage further, and we've got a building model over here, set up to circle. Now we can make this into a helix so that there are infinite number of items, nine tiers. We made this 20 tiers, and you would have seen them without overlap, and you get a basic understanding of the data from that perspective. Looking at this again through not the helix model, not that, but through building. So we go to hex model. Here we have a problem because we've got overlap of data, and there's no optionality of the helix model within that at this point in time. So hexes require a clean 6 structure for it to operate on and to be seen correctly. Just taking the data and switching it back to building quickly gives you a correct reflection of what the data actually represents. Now, how do we get this data into a JSON format for quick recovery, not just drop in of the system, but if you're going to bring it back, it doesn't bring it back as you have set it up. It brings it back in totality at the end point. So we go like that, and we go to the top here. We would download JSON model, come to the download section, open up the file, take this file, rename it, a couple steps here, rename, and we'll call this HPI JSON. HPI JSON, which is going to be obvious because of the ending, so let's just call it HPI discovery, discover. Get it there, Control exit, come to find discover in the document section, and just paste it accordingly in the place that you'd like it to be. I had it in Discovery before, and here we are in the Discovery directory. And we're going to paste it in. Yeah, just sort of go in. There it is, Discovery JSON. And let's make sure that we can get back to this point. Come back here and let's upload that file. And there it is there. And now we're going to open it. Defaulted it. And there it opens as a JSON file. Okay, so to go through that again, over here we have got the upload function of Excel and CSV. Here's the upload function of JSON, which you've just done and executed. And there's the download function if you want to download it. Adjust the data of the keeping the index as much as the same as you can possibly do, otherwise you're going to change the format. Until you've got your indexing handled, the system is still going to be subject to correction. But here we have a nice system and it's fully portrayed. So what else can we do from there? We've shown all the different features. The value concept we understand. We've done that prior in the ROSE model. And the building models attributes we've discussed. The question is, how do you want to see it? You might want to see it slightly differently. You might want to see it as spheres instead of cubes. You automatically change that. Maybe that's a better representation. You might enjoy that better. But numerically, actually calibrated exactly like you'd expect. And of course, everything is tabulated and cross-tabbed throughout the system, and everything uh, pans out quite correctly. Okay, done that. We could change that to a grid, which would do, I think Circle and Helix is probably the most applicable in this case. You can change your XY count and your height parameter. That will apply uniformly throughout the system. You can change the sizing of it. Rebuild that and it will change accordingly. We can go back to where it was. We can do something that we haven't covered yet, and that is invert the values. If they were negatives, it would show them this. Now, if I invert values, they're going to go all the way underneath. You can imagine that negative values would be projected as positive values in this case. And then we have falling animation. That's interesting. Should have done that earlier. Have a look at this. That's just over time. But it's filling up over time, as you can see. That is the concept of the falling animation as attributed to that particular item. So with that said, we now time out for this section. We'll stop here and continue later on with more complex applications.